is an ideal gas problem that also involves density. So for problems like this, if it wants to know the new density of the gas, that's basically like asking the new volume of the gas. We just have to make one more step. So let's look at this as an ideal gas problem. Okay, so we know that the number of molecules remains constant. It's given in the problem. We know that T1 is equal to 338 Kelvin, and T2 is 298 Kelvin. We know that P1 is 1.0 atmospheres, and P2 is 2.5 atmospheres. Now, I didn't convert pressures into pascals because when you're doing ratios, the units don't matter. The exception to that rule is with temperatures, right? Because remember that the way that temperatures work, if you're doing delta T, then that can be degrees Celsius or Kelvin. But if just T appears, it has to be Kelvin. Okay, even if it's a ratio, right? Because see, the difference between 65C and 25C, that's a pretty big ratio, right? That's 2.5 to 1. But 338 to 298, those are much closer, so it makes a difference. You've got to do ideal gas problems in kelvins every single time. Okay, with that said, the ideal gas law, of course, is that PV equals NKT. If I isolate for V and solve for the ratio, I get V2 over V1 is N2 over N1, K over K, T2 over T1 over P2 over P1. Okay, and that is N2 over N1 is 1, K over K is 1, T2 over T1 is 298 over 338, and P2 over P1 is 2.5. So that works out to be 0.353. Now, we don't know what V1 is or V2, but we do know the original density, right? We know that rho 1 is 0.284 kilograms per cubic meter. And we know that rho 2 is basically, I guess, M2 over V2. Well, we're going to use the same trick that we used with the ideal gas law when we have incomplete information. And that is, I'm going to solve for the ratio. So rho 2 over rho 1 is M2 over M1 times the ratio of V2 over V1. Now M2 over M1, that's just 1 because the number of molecules doesn't change. And V2 over V1, well, I just calculated that. It's 0.353. So this works out to be 2.84. Therefore, rho 2 is equal to 2.84 rho 1, which is 0.81 kilograms per cubic meter. Probably should just keep that as 2 sig figs.